Hello everyone. Hello everyone. So today we are going to start with a LeetCode problem which is called happy number. So a happy number is a number defined by the following process. It starts with any positive integer, replace the number by the sum of the square of its digits. Repeat the process until the number equals 1, where it will stay, or it loops endlessly in a cycle which does not include 1. Those numbers for which the process ends in 1 are happy. So we return true if n is a happy number and false if it is not a happy number. So for example, we have n is equal to 19. We have in the units digit we have 9, and in the tenths digit we have 1. So we are going to square the individual digits of 19, and we get 1 square plus 9 square, we get 82. And again we square the individual digits of 82, and we get 8 square plus 2 square, we get 68. And we square the individual digits of 68 and we get 100. And finally in the last step, when we square the individual digits of 100, we get 1. So if we get 1, then our loop terminates and we return true. However, in certain cases like here in the example given 2, and when n is equal to 2, we get false, because when we follow all these steps, we do not get the any final result as 1. So we're going to return false. So we see here that it follows the same principle. Xy is equal to, we square the separate digits of xy, and then we get zw, for example, it's a new number, and we square the individual digits of the new number, that is a reduced number, from xy, that is zw, and we square the individual digits of zw, and then we get uv, which is again a reduced number. So the method we are going to follow here is that we are going to store all our zw, uv, and all those reduced numbers from the previous number that we square the individual digits of, and we get a reduced number. So these numbers we are going to store inside a set. We are going to use a data structure called set. In this question, we see that it's many numbers follow a loop. So it starts with A and then goes to B and then C and then D, and after it comes back to A, again the loop repeats from A, because it has reached the number A, so it has to go to B and then C, D, and it goes on in an endless cycle. So it could be this kind of loop also, where it starts from B, where the endless loop starts from B and then C, D, and then again goes to B, and from B again keeps on looping. An example where this endless loop occurs is over here, where we do not reach the 1 at all. We do not get 1 in the right hand side. So we see that we start from 3 square 9, and then we get 9 square 81. We square the individual digits of 81, we get 65. We keep doing that, and then we see that once we have reached 16, we square the individual digits of 16 and we get 37. But have you seen, we have already got 37 in our right hand side before. So here we have already gotten 37, and so we see that this 37 has been repeated. So when we see that, when we okay, for example, we're going to store all the right hand side numbers inside a set. Okay, so we push 9 into a set, after we get 9. We push 81 into a set, after we get 81. Then we push 65 inside the set, then we push 61, then we push 37. We keep pushing all these numbers, and finally when we get to 37 again, we check whether the 37 is present in the set or not. If we see that we have already pushed 37 earlier inside our set, then we are not going to push it again. We see that 37 has already been present in the set, and so we see that it is present in the set, and we terminate and we return false. However, if it is not present in the set, and then we keep on pushing into the set, um, yeah, then after reaching 1, if we check that, we find that we get 1 on the right hand side, then we can return true. So we are going to implement a set data structure for here in this question. So we're going to store all these numbers inside the set, and then we're going to check by pushing each number inside the set, and we're going to check if that number has already been pushed inside the set earlier. So that's what we're going to do. So going to the coding part, we're going to initialize the set, and let me name the set as GP. Then I'm going to give a value, then a num. So while we're going to enter into a while loop, I'm giving while of 1, so that the loop goes on infinitely. Then our value will be equated to 0 initially. Then another while loop, while n, which is the number or the argument which is specified here, which is technically our number. Then num is equal to n modulo 10. We're going to get the remainder. That is, we're going to get the units digit first, and then we're going to proceed to the other digits, so that we can get all the separate individual digits of the entire number. We want to get each number one by one, and then after getting each number one by one, we are going to square the each digit. We're going to square each digit that we're going to get from the number, and we're going to continue the process for the other digits. So that's why we're going to divide by 10, and then we're going to get the quotient here. So after this while loop gets over, we are going to give an if condition here. If value is equal to 1, then we are going to return true, which means it is a happy number. Means we have reached value 1, so congratulations. However, if else if gp dot find of value is not equal to gp dot end of, then we will return false. So what this means here is that if the value is already present inside the GP is the set. So if the value is already present inside the set, then we are going to return false. If the value is already present inside the set, it means that the loop is in an endless loop. For example, if the value here 37 is already present in the set, then that's what we are checking for in that if statement. If 37 is already present in the set, which is that is 37 is present, so we are going to return false, because it's already present. If it's already present, then it is in an infinite or endless loop, and it is not a happy number. However, if the value is already not present in the set, we are just going to push it into the set, right? It's a new value. If it has not occurred at all, so it's a new value. So we will just push it inside the set. We want to push the value inside the set, and after pushing the value inside the set, we have to initialize the n value to the new reduced value, right? So because we can't just use for example, we take this 19, 1 square plus 9 square is 82. We're going to use the reduced value here. So we're going to split the 82, that is the reduced value, into two digits, and then we're going to square each of them to get 68. And now again we're going to use this reduced value 68. We're going to square each of the digits of 68, and then we're going to get 100. So we have to initialize the n variable to the new reduced value. So that's what we're doing here. So after this all happens, we're going to terminate, and we're going to return false. And I'm going to check. Oh, I missed one. Have I closed all the brackets? No. Plus n equal to has to be together, I guess. Yes. So that's it. Thank you for watching.